How did humans go from cavemen to electric cars and interplanetary spaceflight? You are holding a device that would seem like magic to every single human who lived before the year 1900. It connects you to billions of other people instantly. It contains more information than the entire Library of Alexandria, and you use it mostly to look at pictures of cats. Meanwhile, outside your window, there are machines that can drive themselves to destinations, and humans are literally living in space right now. We went from caves to the cosmos in what is, cosmically speaking, a blink of an eye. And the wild part is that nobody planned it. There was no ancient prophetic cave drawing that said, "Hey everyone, let's figure out electricity and then build rockets." We stumbled into the future almost by accident, one small discovery at a time, and the path we took reveals something profound about what humans actually are. Let's start with the basics. About 300,000 years ago, your ancestors were living in caves, not by choice necessarily. Caves were just good real estate. They had shelter, they had protection from predators, and importantly, they didn't require building permits or dealing with difficult neighbors. Life in these caves was, by any modern measure, absolutely brutal. We're talking about a life expectancy of maybe 35 years if you were lucky. That number is deceptive, though, because most people didn't make it to 35. If you survived being born, and many didn't, and if you survived childhood, you still had to not get eaten by a lion, not get infected by a simple wound, and not starve during winter. It was essentially playing Russian roulette every single day, except the gun has way more bullets. But here's where it gets interesting. These cavemen and cavewomen possessed the exact same brain that you have, same neurological hardware, same capacity for abstract thought, creativity, language, and problem solving. The difference wasn't intelligence, the difference was knowledge. They didn't know anything, but they were going to figure everything out. The first major breakthrough came with fire. And I know, fire doesn't sound as impressive as electricity or space travel, but fire was genuinely the game changer that made everything else possible. Fire gave you heat without expending your own body energy. It gave you light, which meant you could work and socialize at night instead of just sitting in the dark contemplating your mortality. It cooked food, which made it easier to digest and more nutritious. And crucially, it was a tool that you could control. Unlike a rock or a stick, fire was something you could actually direct and shape to your purposes. Early humans didn't invent fire. That would take another couple 100,000 years of accumulated knowledge. They just stole it. They found it after lightning strikes or volcanic activity and then figured out how to keep it going. And that steal, that one act of seeing fire and thinking, I wonder if I could use that, set off an entire chain reaction of human progress. Then came tools. Now, humans had been making tools for a while, basic sharp rocks and such, but around 2.6 million years ago, we started getting serious about it. We made stones with purpose, we designed them, we imagined what we needed and then created it. This is the moment when human beings stopped just responding to the environment and started actively reshaping it to fit our needs. And once you have that mindset that you can look at the world and go, I could make this better, you've opened a door that never closes. Every invention that follows is just a more sophisticated version of that same instinct. Fast forward to about 12,000 years ago, and humans did something even more radical. We stopped moving around. We invented agriculture. This seems straightforward now, but at the time it was honestly kind of stupid. Why would you give up the hunter-gatherer lifestyle, where you foraged and hunted and had plenty of leisure time, to stay in one place and work the land constantly? You would develop back problems. You would get diseases from living too close to each other. Your diet would actually get worse in a lot of ways. But agriculture gave you surplus. For the first time in human history, one person could grow enough food for themselves and three other people. Suddenly, you didn't need everyone farming. You could have specialists. You could have tool makers, priests, soldiers, administrators, artists, and people whose entire job was just thinking about why things work the way they work. You could have scientists, essentially. The ancient civilizations rose on this foundation. The Egyptians, the Mesopotamians, the Indus Valley Civilization, the Chinese, they all built on the same basic discovery. If you stay in one place and cooperate with a lot of other people, you can build incredible things. They created mathematics, writing, architecture, and bureaucracy. They developed laws and governments and organized religion. They stared up at the stars and wondered what they were made of. They didn't answer those questions, but they asked them. And asking the questions, having the leisure time to wonder about things that don't directly help you survive, is actually the prerequisite for all progress. Then progress slowed down for a while. The Roman Empire happened. The Middle Ages happened. For about 1,000 years, Western civilization basically went to sleep. But in other parts of the world, things kept moving. The Islamic Golden Age produced mathematics, astronomy, medicine, and philosophy. Chinese civilizations developed gunpowder, printing presses, and incredible engineering. Knowledge kept accumulating somewhere, even if it wasn't accumulating in Europe. But when the Renaissance hit, something changed. Humans developed this new obsession, testing things. We developed the scientific method. Instead of just accepting that the world works a certain way because old books said so, we started conducting experiments. We made observations, we developed hypotheses and tested them, and when they were wrong, we changed our minds. This seems obvious now, but it was genuinely revolutionary. For thousands of years, we'd been accumulating knowledge passively through experience and careful observation. Now we were actively interrogating reality itself. Galileo pointed a telescope at Jupiter and saw moons. That observation, 4 small dots of light, contradicted everything the authorities claimed about how the universe was organized. But he was right, the moons were there. They existed regardless of what the authorities believed, and that discovery opened the floodgates. Newton came along and figured out gravity. He realized that the same force that makes an apple fall is the same force that keeps the moon orbiting Earth. The universe was not magic. It was not the whimsy of gods. It followed rules. And if it followed rules, you could understand those rules, predict behavior based on those rules, and use those rules to build things. This is the moment when physics became possible. This is when engineering became a science instead of an art form. Over the next few centuries, humans figured out so much so fast that it gets hard to keep track. We understood electricity. We understood magnetism. We understood that they were related. We figured out the periodic table of elements. We realized that matter was made of atoms, and atoms were made of even smaller particles. We understood light and waves and energy. And with each discovery, we didn't just add to a list of facts. We discovered that we could manipulate reality itself. We could use electromagnetic forces to create movement. We could use combustion to generate power. We could use electricity to transmit signals across vast distances instantly. By the 1800s, we had railroads. By the early 1900s, we had cars. And here's the crazy part. A car is not a mysterious object. It is just applied physics. You burn gasoline, which releases energy. That energy moves pistons in an engine. Those pistons turn a crankshaft. The crankshaft transfers power to wheels. Wheels move. The whole thing is just Newton's laws and chemistry. The Wright brothers looked at birds and then built a flying machine using the exact same principles. Their first plane flew for 12 seconds. 66 years later, we landed on the moon. 66 years. And the thing that made all of this possible was not genius. It wasn't some special DNA that Europeans possessed. It was accumulated knowledge. It was the ability to write things down so that your discoveries didn't die with you. It was universities where people could study what previous people had learned. It was the scientific method, where you didn't just accept ideas because they came from authority. It was the printing press, which meant knowledge could spread to lots of people instead of being locked up in monasteries. Once you have that system in place, Once you have a way to build on previous discoveries, to test ideas rigorously, and to share knowledge, progress becomes inevitable. Not automatic, but inevitable. You will figure things out, you will keep figuring them out, and each thing you figure out makes it easier to figure out the next thing. So by the 1900s, humans had gone from caves to electricity, from caves to flight, from caves to the beginnings of an understanding of how atoms work. And then the 20th century happened, and things just accelerated wildly. We split the atom, we harnessed nuclear energy, we cracked the genetic code, we invented computers, we developed lasers and semiconductors and synthetic materials, we sent robots to other planets, we created the internet. And here's what's wild. Most of this stuff was not invented to be practical. The laser was invented by scientists playing around with photons. It had no intended application. Computers were invented to calculate missile trajectories. The internet was invented by the military to survive a nuclear war. Penicillin was discovered because Alexander Fleming was lazy and didn't clean his lab. We keep stumbling into the future almost by accident, but the momentum is undeniable. Once you have knowledge, you can't unknow it. Once you know that atoms exist, you're going to figure out what you can do with them. Once you know that electricity and magnetism are related, you're going to invent generators and motors. Once you know that you can encode information digitally, you're going to build computers. Once you can build computers, you're going to network them together. And once they're networked together, you get the internet. The pace of change has become so fast that it's genuinely disorienting. Someone born in 1920 lived to see the invention of the airplane, radio, television, antibiotics, nuclear weapons, the computer, and the internet. That's an entire technological revolution every couple of decades, and the time between major breakthroughs keeps getting shorter. Today, we have electric cars that drive themselves. We have spacecraft that land rockets vertically for reuse. We have people living in space. We have created artificial intelligence. We are literally editing genes. We have technology that would have seemed like pure fantasy to someone from just 50 years ago. And the knowledge required to understand this technology, the theoretical physics and materials science and computer science, it all built on previous discoveries. It's all part of one continuous chain that goes back to someone sitting in a cave wondering what fire was and how to use it. The path from caveman to spaceman is not a story about human genius. It's a story about human curiosity and our weird ability to build on each other's work. It's about the fact that knowledge is cumulative. Once someone figures something out, you don't have to figure it out again. You can build on it, you can take it further. And if you have a way to write that knowledge down and share it and verify it, you get exponential growth. You get a future that your ancestors couldn't have imagined. And the wild part is that we're not done. We're nowhere near done. The knowledge we have now, the technology we can create now, is going to enable discoveries that we literally cannot predict. Someone studying physics right now might unlock something that changes human civilization in ways we can't currently conceive of. That's how rapid the pace of change has become. So the next time you pick up your phone, or you see an electric car, or you watch footage of humans in space, remember what it took to get here. It took 300,000 years of small discoveries. It took fire and tools and agriculture and writing and mathematics and the scientific method and printing presses and electricity and chemistry and physics and computer science all stacked on top of each other. It took billions of humans, most of whom will be forgotten by history, each contributing a tiny piece to the massive puzzle. We didn't go from caves to electric cars because we became smarter. The hardware hasn't changed much in 50,000 years. We went from caves to electric cars because we figured out how to accumulate knowledge faster than we forget it. We developed a system for interrogating reality and building on previous discoveries. And that system, once you turn it on, keeps going. It just keeps accelerating. The caveman and the spaceman have the same brain. The difference is that one of them is standing on the shoulders of 300,000 years of accumulated human progress, and that, more than anything else, is the story of how we got here.